Hey everybody, in this video we're going to piece together the ideas of arcs and sectors and areas of triangles, and we're going to try and apply these so we can see how they all kind of work together, or how they can work together if needed. So we have our circle with the center at 0, radius of 6 centimeters, QR is 11.2 centimeters, and POQ, the angle POQ, is 1.25 radians. Alright, so QR is 11.2, POQ is 1.25, and our radius, we've got 3 measures of our radius going from O out to the circle, and those 3 sides are all going to be measurement of 6. So we're going to start by finding the area of triangle POQ. So we've got 2 sides and an angle, so we can use our formula for area of a non-right triangle, AB side sine C. So we'll plug in our values, 1/2, 6 times 6, sine 1.25. Now, keep in mind this 1.25 is measured in radians, so when we're about to put this into our calculator, we need to make sure that we're on radian mode. So check that, and we calculate out, and we get 18 times 0.949. That's rounded a little bit to make things a little easier for us. And when we calculate that, we get an area of approximately 17.02 centimeters squared. Alright, so now we need to find the next piece, the area of sector POQ. Okay, so the area of sector POQ, so remember that when we're finding the area of a sector, the area is proportional to the circle, and the angle measurement of 1.25 is proportional to the angle measurement of the whole circle, 2 pi. So we're going to take a proportion of this circle based on our angle measurement, so we say theta over 2 pi. Now this isn't the same theta as the black here, because of course we're talking about 1.25, but so this is just kind of us going through the motions here of how to find the area of the sector. So we're going to take the proportional piece of that angle measurement, and we're going to multiply it by the area of a circle. So before we plug values in, we can do a little simplifying here, knock out those pi's, and we get theta r squared over 2. So now applying it back, we get our area is 1.25 times 6 squared, our radius squared, and divide that by 2, and punch it into our calculator. We get 22.5 centimeters. Centimeters squared, excuse me. So now, as we find the last piece, letter C, we're just going to find the area of the shaded space. That's going to be the area of the sector minus the area of the triangle. Nice and easy. So we got 22.5 minus 17.02, and we get a value of 5.48 centimeters squared. Alright, so for the second half of this problem, we're going to find the area of triangle QOR. So QOR is this triangle here. So we've got our 3 sides, and we do not have an angle measurement. Now, we need an angle measurement to do our area of a non-right triangle. And since we have all 3 sides, we could pick any angle. We could pick angle Q, R, or angle 0, or angle O. Since looking at problem E, we're going to need to find the angle of PMR. That means we're going to need the length of arc PMR. We're going to need to know what theta is. So instead of choosing Q and R, I'm going to choose angle O to find the measurement of that angle, because I'll be able to use that later. Okay, so we'll use the cosine rule to find angle O, and the cosine rule of angle O is 6 squared plus 6 squared minus 11.2 squared divided by 2 times 6 times 6. Now, if you're not familiar with that cosine rule, make sure that you pop back to our other videos where we are talking about how to find the cosine rule and how to use that cosine rule, where these values come from, and so on. So we punch it into our calculator. Our cosine O is negative 0.7422. Do our inverse cosine of that value, and we get angle O is equal to 2.407 radians. Again, keeping it in radians because we're talking about the circle in radians. So now we can use this with our formula for area of a triangle like we had in the first problem, and we have 1/2 6 times 6 times sine 2.407 radians, and we get 12.1 centimeters squared. Now the last piece, let's see if I can squeeze this in here, is looking for the arc measurement of PMR. So we've got this M out here to kind of help identify what arc we're talking about, since we have 3 different arcs that we could potentially be talking about. So arc PMR. So looking at how this is built, we're looking at the measurement of angle theta, and this goes, again, the arc length is going to be like the proportion of the circumference. So we're going to do the same thing like we did in letter B. We're going to find the proportion of that circumference. We're going to say theta is equal to 2 pi minus 1.25, and that is equal to, minus 2.407, and that gives us a measurement of 2.63. Now we can use this to find the proportion of PMR to that angle. So our length is going to be 2 pi, theta over 2 pi, times the circumference, which is 2 pi r. So we're taking a proportion of the circumference based on the measurement of angle theta. We do our simplifying, and we have a real nice easy formula of our theta, or our length equaling theta times r. So we have 2.63 radians times 6 for our radius, and we get 15.8 centimeters for the length of PMR. So hopefully this should be just kind of a review for all of these concepts, just kind of piecing everything together, seeing how when you have a somewhat complicated looking diagram, you can actually break it apart into smaller pieces just using the things that we've already learned and talked about. So if you're unfamiliar with any of those, always pop back to one of our older videos and you can look at those to help you out with some of those supporting pieces. But I hope this helps, and we'll talk to you in the next video.